Hi, welcome to inserting the node in AVL tree. Then we will check the balance factor of the tree. Is it AVL tree or not? So here we are going to use RR rotation. First we are having the list of nodes 50, then 40, then 60, then 55, then 70, then 80. So these are the nodes given to us to create the tree. Then we have to check is it balanced tree or not balanced tree in the form of AVL. First we are creating the root with the 50. Yes, it is created. Then we are going to add the node 40. So 40 is less than the 50, so which is going to add as a left child. Then we are adding the 60 in the tree, so 60 is greater than the 50, so which is added as a right child. Then we are adding the 55. 55 is greater than the 50, so going to the right subtree. Then 55 is less than the 60, so which is added as a left child of the 60. Then we are adding the 70. 70 is greater than the 50, which is going to the left subtree. Then we are checking with 60. So for 60 here, the 70 is greater than the 60, so we are adding as a right child. So here the 60 is earlier not having the child, so we are adding the 70 as a right child. Then we are again, now we have to check balance factor until here. When you are checking the balance factor, right? So always you have to check the balance factor whenever you are adding the node, right? So now when you are checking the balance factor for this leaf nodes, height of the left subtree and height of the right subtree 0. Then this is also leaf node, left subtree height is 0, right subtree height is 0, so 0. Then here also, right here also you will get the left subtree height is 0, then right subtree height is 0 as of now. Then it is 0. Then height of the left subtree is 1, then height of the right subtree is 1, so it is also 0. Then when you are checking the balance factor for the 50, except this one, so now height of the left subtree of the 50 is 1 minus height of the left subtree. So two paths are there, so in this path also 2, this path also 2, so we can take maximum of height 2 comma 2, so we can take 2, so 1 minus 2, which is minus 1. So now until now, which is satisfying the balance factor of AVL, all the nodes satisfying the AVL tree property. So now we are going to add the new node 80. Now we are going to add the new node 80. So when you are adding the new node 80, we have to check with the root. So if 80 is greater than the 50, so we are going to right subtree. Then 80 is greater than the 60, again we are going to the right subtree. Here child is available, so now we are checking with the 70. So 80 is greater than the 70, so 70 is not having the right child, so that 80 is going to add as a right child of 70. Now you check the balance factor. So for this, there is no left subtree and right subtree for all the leaf nodes, so it will be height of the left subtree and height of the right subtree 0. So for all the leaf nodes it will become 0. Then now you check the balance factor for remaining internal nodes. In the internal nodes, so this is the left subtree is null, so 0 minus this side 1, so 0 minus 1 minus 1, so minus 1. Then here for 60, left subtree height is 1, then right subtree height is 2, so two edges are there, 1, right, then 2, so two edges are there, so 1 minus 2, it will be minus 1, so minus 1. Then height of the root, in the height of the root when you are checking, uh, left subtree height is 1, so 1, so right subtree, two paths are there, this is one path, so maximum of height 2, then one more path is this path. So three edges are there, one, two, three edges are there. So three, so maximum of 2 comma 3. So 3 is the maximum value, so we are taking the maximum. 1 minus 3 minus 2, so which is not satisfying the balance factor of AVL, the 15 node 50. So now in this location, why it was happened? Because of adding the node in the root right subtree of the root, and also as a right child. So we have to perform. So where it is not matching the balance factor is not matching in this node. So we have to perform the RR rotation in this place, because here only the balance factor is not matching. So we have to perform the rotation operation here. So when you are performing the RR rotation in anti-clockwise, the top node 50 will become as a child. So when 50 is becoming as a child, we should take care of the children of the 50. Here 50 is having two children, and 60 is also having two children. So when you are performing the anti-clockwise rotation, you will get the 60 will become the parent. When 60 will become the parent, it will get two children. 50 is one child, 70 is one child. So 50 will become the left child of the 60. 70 is as usual right child. So what about this 55? 55 should be added as the right child of 50. So that's what you look at, that once 60 becomes parent, right? So its left child should be added as a right child of its parent. So previously 50 is the parent to the 60. Now 60 becomes parent to the 50. So its left child should become your right child of the previous parent. So now you calculate the balance factor, you will get 0 minus 0. So here null, so 0 minus 1, so minus 1. Here for all the leaf nodes 0, then internal node 1 minus 1 0, so this is also 0. Again when you are calculating the balance factor for the root, so here one path, so two edges, here one more path, two edges, so maximum of 2 comma 2. So 2 minus right subtree only one path, so 2, it is 0. So now it is satisfying the AVL property of balance factor 0. So all the nodes are having 0 or minus 1 or 0. So it is satisfying the AVL tree property. So now it becomes the AVL tree. Thanks for watching.